Hey everyone, it's Mrs. Fella. All right, today I have a lesson for you on areas and similarity. So do you guys remember what similar means? It's when you just take something and enlarge it and it stays the same. So we're just going to explore the area of that. So say you are asked to create a banner for school or something. This is the example they give us. And you start out with your banner at 1 foot. So see that they have 1 foot, and then we're going to explore making it larger, 2 feet long. So we'll start with 1 foot long, and we're going to make it 2 feet long. So the big question is, does the area double? Since we doubled the sides, right? We went, our side ratio is 1 to 2. So most people say yes, the area doubles. So you have to explore that and see if that's actually true. So if the area doubled, 2 of these little banners would fit into our doubled one. And that's not true, it's not enough. We can actually fit 2 more. So in reality, it is 4 areas that fit into it. So the area did not double, it quadrupled. So if our ratio is 1 to 2, we now have to square it, and we get 1 squared is 1 and 2 squared is 4. So it's really a 1 to 4 ratio. Okay, so if you don't believe it, you can try it again with the 3. Let's say I take the original, and instead of 1 foot, we want it to be 3 feet. So technically, if the side ratio is 1 to 3, the area ratio would be 1 to 9 because I'd have to square the sides. So is that true? Do 9 of the little banners fit in? Well, it turns out, yes, there's 4 of them. And then if I'll have to do this quickly, but put them in, I get 5 more across the top, and 4 plus 5 is 9. So that means we are now going to do a quick thing of notes. I'm going to give you a problem at the end of this video, so pay attention that you're going to try at home. Okay, so it's actually times 9, not times 3. Very important. All right, so for your notes, we're going to kind of make a quick little summary of that. And if you guys remember when we took 2 similar shapes, like enlarge them, and say the ratio was A to B, just some number, 1 to 3 or 2 to 4 or whatever, the perimeter ratio stayed the same. Do you guys remember that? There was some lesson we did where the perimeter ratio was also A to B, and the side ratio was A to B, so they stayed the same. So that's really important. What we need to add now is that the area ratio is actually squared. Okay, so look at that, write that down in your notes somewhere. If it's asking you to do perimeter, it stays the same ratio, but area, you are gonna have to square it, and everybody forgets the squaring part. All right, now we're gonna do an example with actual numbers. So here we go. All right, say I have 2 shapes. Whoops, there goes part of my setup. Okay, say I had 2 shapes that are similar, such as, all right, is this in the frame? I have to watch and make sure. Say I have 2 pentagons, and I don't know if they're regular. This has nothing to do with regular like all the other lessons did. All I know is they are similar to each other. And say the ratio was 3 to 5. And say you're given the perimeter of this little one is 15. And your task is to find the perimeter of the large one. Just like that. And you're saying, well, wait, I don't know all the other sides, and it's not regular, so I don't know. That's where the ratios come in. So if your side ratio is 3 to 5, then your perimeter ratio is also 3 to 5. But you're going to use that to actually find it. So we're going to go 3 to 5 is our ratio, and it's going to equal 15 to the unknown perimeter that I'm trying to find. Okay, so Perimeter stays the same. Area is the one that's going to square. So now all you would do is cross multiply. So 3 times P equals 15 times 5. And that is 75. And then you divide and you get 25. Okay, so that's the procedure. Pretty basic, pretty easy. We've done that before. Now, what about area? So say you are given 2 similar shapes, like you see here, and say the area is given to you and it's 15.5. This is of the smaller one. What's the area of the larger one? What do we do now? So we're going to take that 3 to 5 side ratio, and first you have to square it. So 3 squared, 5 squared. So the real ratio is actually 9 to 25. Okay, do you see that? 9 to 25. So I can now say 9 over 25 equals area over area. So I did little to big, so I'm still going to do little area to big area. I'm going to call it X, call it A, call it whatever you want. Now it's just a big cross multiplying problem. So let's try that. So 15.5 times 25, I get 387.5. Make sure that's in the frame. And then I'm dividing both sides by 9, and you get about 43.05. Missing area. I don't have to do the 1/2 apothem times perimeter because it's not regular. Okay, so let's see if you guys can do one. So I'm going to give you one to try, and I'll give the answers at a different time. Okay, so let's try it. So say you had 2 hexagons, and we don't know if they're regular, so I'm just going to draw them kind of off. Little one, it's similar to a big one. All right, and the side ratio is 6 to 14, that's given. And say the area of the little one is 18, and you have to find the area of the big one. So hint, hint, don't forget to square those ratios before you cross multiply. Okay, so try that out. Hopefully it shows up in my screen. Okay, and then we'll go over the answers at another time or with another video. Okay, goodbye for now.